Welcome back. With Lagoa we have the ability to simulate cloth, which is actually a pretty useful feature of Lagoa. Now, one important thing before we get into cloth, Lagoa is actually not recommended for doing any type of complex cloth simulation that requires, say for example, moving characters or anything that's going to be moving around, pulling cloth around and doing some advanced or complex things. If you're going to be doing anything like that, like let's say a cape on a character or a dress on a character that's animated and moving around and jumping and doing all kinds of stuff, then you want to stick with using SciFlex cloth, which is already built into Softimage. So you want to go that route. So Softimage gives you the ability to use cloth with SciFlex or use cloth with Lagoa. So for simple things, you could use Lagoa. So let's have a look at an example how to go ahead and use Lagoa to create some cloth from scratch. Okay? So what I'm going to do first in this scene is I'm going to create everything from scratch. So we're not going to open up an example scene. We're just going to do everything ourselves right here. So I'll go to Primitive. I'm going to grab myself a polygon mesh grid. And let me increase the size of this a bit. Now, very important when you're doing Lagoa cloth simulations, you want to make sure that the topology of your polygonal mesh is pretty evenly spaced out, kind of like this. You don't want to have like a lot of detail on one side and then the rest is very, very simple with very few triangles. You want to keep all your vertices and polygons and things nice and even throughout the entire mesh, or else you may get undesirable results. So with this done, I could increase the subdivisions of the geometry, which would obviously look better, but the problem is the simulation is going to run pretty slow. So what I'm going to do is I'm just going to use a grid that's 8 by 8 in subdivisions. So it'll just simulate much faster. I'm going to call this cloth. I'm going to go into point mode, take all the vertices, and I'm just going to turn them 90 degrees this way. What we're also going to need is a collision object, so I'm going to go to polygon mesh, and I'll just get myself a simple sphere. I think that'll suffice. So for the radius, maybe I'll go with something like 12 will probably work out fine. I'm going to call this collider. And just like with other Lagoa simulations, if you're going to have a lot of colliders, then what you want to do is you want to put them in a group. It's the same deal here with cloth. Let me hide the grid. And then finally what I'm going to do is I'm going to create a null. I'm going to move it up. Let me go to a front view, and I'm going to place it about right here at the top of the cloth. Let me go back to a camera view here real quick. Another thing I want to do is I want to go to the nulls options. I'm going to rename this. I'm going to call it constraint 1. And I'm also going to make this rings. And I'm going to change the size to about maybe 4 will work out just fine. The size of the null will actually determine the influence area of the constraint. So that's actually pretty important. So I'm actually creating constraints right now. So let me go to the front view here. I'm going to make a duplicate of this constraint and put it over here toward the edge. I'm going to make another duplicate and put it over here toward this end of our little make-believe curtain over here. Switch to shaded mode. I'm going to take the little curtain here and let me go to the model menu set. I'm going to go to material and apply just a simple architectural material to this. I'm going to change. You can make the color whatever you want. I'm going to go with red, increase the roughness, and I'm going to take away the reflectivity and stuff. So it looks like this. Okay. Alright, so we're pretty much done with that. One important thing about Lagoa cloth is you want to make sure that the object you're going to be doing the cloth with, which is this red object right here, this red grid, you want to make sure that the transformations are all frozen. In this case they are, but if for whatever reason it wasn't, you want to make sure you freeze transforms first. You can do that by going to the transform menu and doing it from here. So once you have your mesh ready to go and everything, what you can do is select the actual mesh that you're going to be applying the Lagoa cloth to. Let's switch over to the ice menu set. And what you want to do is go down to the form menu and let's go to simulate and just click on Lagoa cloth mesh. Because I already had the mesh selected, Softimage knows that's going to be the actual cloth mesh. Next thing it's going to do, it's going to ask me to pick a collider. So I'll pick the sphere. And that's it. It's going to hook up everything for me automatically, just like it's been doing in the past. So pretty simple to use. So we'll get the Lagoa setup cloth mesh PPG that pops up over here. And let me go to an ice tree layout. Let me resize this window right here. Okay, so basically this applies an ice tree to the cloth object, and it also applies this Lagoa setup cloth mesh compound that you can see right here. Now what I like to do is I like to go select the compound and explode it. So I'll go to explode compound, and I'm going to go ahead and organize this stuff a little bit better. So here's my ice tree. It looks just like any other Lagoa ice tree, but there's a couple of key differences. So let me go over what these differences are. With Lagoa cloth ice trees, what you're going to get is, instead of an emit grid node or an emit volume node, you're going to get this Lagoa init geometry node over here. So this is for the actual geometry of the cloth. Okay. The other thing you're going to get is this Lagoa transform constraint compound over here. Now, by default, the Lagoa Sim is not using this right now, but what this allows us to do, it allows us to plug in objects that we can use as constraints. Okay, and then we have a material cloth compound over here with some inelastic and elasticity settings. And if we look at the multiphysics node, automatically it has everything turned off under optimization except for the stuff that we're using, which is elastics and inelastics. So pretty useful. You also notice that substeps right now is by default set to 2 instead of the usual 3. So very important stuff to make note of. Alright, so with that done, let me increase my frame range down here to 10,000. And I'm going to go ahead and hit play. You're going to see that the cloth mesh is going to fall down on top of the sphere, and it's actually going to interact with it. You can see it's actually kind of draping over it, and it's solving right now. Let me rewind. I'm also going to turn on my frame rate over here for this. So if we want the cloth to not fall down, we can use constraints. That's what these nulls were for that I created up there. But we'll use those in a bit. The main things that are going to control the cloth right now is going to be the material cloth compound over here. So the actual material node has the elastic and inelastic settings over here that we can adjust and change and alter until you get something that you like. One main thing that I don't like by default is the amount of damping. I think it's way too high at a setting of 3. I like to reduce that quite a bit to even below 1. But it depends on what kind of cloth you're going for, because the damping is really going to make that cloth look rigid and very, very rough. See, now without all that damping, the cloth kind of drapes and falls down in a more natural manner. And you can control the behavior of the cloth using the elasticity settings. So if you want to be less elastic and crumple up a little bit more, you might want to drop this setting down. You also might want to reduce the stretch resistance and the shear resistance if you like. So it's all there for you to play around with and try to get the type of cloth that you want to get. So another important thing here is if we go to the actual Lagoa init geometry node, you notice that we have down here a topology map setting. Right now the resolution map is set to automatic. What this does is it helps to prevent the cloth material from penetrating itself. Okay, so sometimes the cloth will actually fold down on itself, and the actual cloth geometry will start to go through its own self, which obviously doesn't look very realistic. A little bit hard to show you that here because the cloth isn't actually penetrating itself at the moment. So let me see what I can do here. Let me go ahead and create a new polygon mesh grid. This is going to be kind of like a floor at the bottom. Let me make it larger. Make it 200 by 200. That'll probably work out pretty good. I'm going to call it floor, and I want to create this as another collider. So what I'm going to do is I'm going to take the collider and floor, make a group. I'm going to rename this to colliders group. I'm going to drag and drop that down here, and I'm going to replace the original collider with this one, and I'll remove this one. Okay, so that'll work out pretty good. If I hit play, you can see the cloth drops down, interacts with the sphere, and then finally it's going to fall on the floor right there. Back to the Lagoa init geometry node. If you find that your cloth is actually penetrating itself, What you want to do is you want to switch the resolution map to manual mode and then adjust the thickness. Now this thickness parameter is very, very sensitive, so you don't want to crank it up to something like 10 or you're going to get very, very undesirable results. What you want to do is you want to drop this down to something like, I find that a value between 1.25 and 1.5 actually works out pretty good in most situations. Okay, I'm going to leave it on automatic for the moment. And then finally what I'm going to do, I'm going to apply constraints to this object. So very simple to do. I'm going to take all of the nulls, I'm going to make a new group, and I'm going to call this the constraints group, and I'm going to drag and drop that constraints group into my ice view down here. And what I want to do is I want to take the out name and plug it into this Lagoa transform compound over here, the constraint compound. I'm going to plug it into the in name null, and that's pretty much it. Now what you notice is when I hit play, you have these purple vertices up here. Those purple vertices, or these pink vertices I should say, those are the vertices that are being constrained right now by the individual nulls. Okay, so if you see a pink vertex, it's a vertex being constrained. Right now the cloth doesn't fall. It's kind of draping almost like a curtain or something on a window. And if I take the sphere while the simulation is playing in the viewport, I can actually bring this up and start to interact. Now you notice that the sphere kind of has trouble there where if I go really fast it goes into the cloth mesh, it penetrates it and stuff. But you can see I could use the sphere to interact with this object right inside the viewport, and it behaves as expected. Pretty cool little fun stuff to do. Now again, if you notice that the your collider is going right through the object, then what you need to do is you need to increase the actual time steps. So you might want to go into the multi-physics node and increase this sub-steps over here for the time step to a value of 3. You've also got elastic steps and inelastic steps. So if you see that the inelasticity or the inelastics or the elasticity are having trouble being calculated, you may want to increase those individually. Alternatively, another thing you can do is you can go down here to the simulation settings property of the actual cloth mesh, open that up, and use subframe sampling the same as we did before in a previous video with another example. So this actually can help you out here. So you might want to increase subframe sampling to 2, test it out. If it works great, then you're done. If you still notice that you're having trouble with your project, then you might want to increase that to 3 or higher or whatnot until you get something that you like. Again, increasing the subframe sampling is going to increase the accuracy of the simulation, but it is going to make it take longer to simulate, so that's one thing to keep in mind. So now you can see it does a much better job. By increasing the sub-steps on the time step parameter of the multi-physics node, I was able to get it to react a little bit better. So now when it comes in here and makes contact, it doesn't just go through it that easily. Right there it did, because I'm moving it kind of fast. You can see it's going about 12, 13 frames a second, which is pretty slow. But me, I can move the sphere really, really fast. So if I move it too fast, it's going to go right through the mesh, which is actually pretty normal because obviously it's passing by too fast for the mesh to be able to react. So that's a situation where you may want to go in here and increase the subframe sampling, try to get a better result. So let me close that. Let me replay this from the beginning. And now it's going really, really slow, but it's going to do a much better job of realizing when the sphere is actually hitting the cloth mesh and then reacting to it according to all the physical parameters and stuff that are set in the material cloth setting, that kind of stuff. But you can see now it's going really, really slow. So what I'm going to do is I'm just going to stop this thing, set it back to subframe sampling of 1, leave it on sub-steps of 3. So creating cloth with Lagoa is actually very easy. The tough part is setting up all the settings and stuff and just working on your project and doing some creative stuff. So that's pretty much it. That's pretty much all there is to Lagoa cloth. Setting up constraints is very easy. Setting up colliders is very easy. And the rest is mainly just going into the material cloth compound here and adjusting the material settings for elasticity and stuff like that to get yourself a piece of cloth that looks more like a burlap sack or can look like silk or whatever you want. So adjust these settings to your liking for your projects. So that's pretty much going to do it for creating cloth with Lagoa. In the next video, I'm going to show you how to do cloth advection, which is actually a pretty neat feature of Lagoa. I'm going to show you how to do that next.